So the next topic I'd like to talk about is about namespace and scoping. Namespace and scoping. Again, as an analogy and very broadly, not an a complete one-to-one equivalent, but a broad idea about what namespace is in a program, in Python's program, is the ability to refer to the same variable name in different parts of the program. So in different parts, in different programs, when we use the example, the variable name x, we are able to use x even though your peer, your teammate, might have also used x for something else in his or her Python program. We don't have to worry about it. More importantly, the system modules, the built-in modules, might have also used X, and because it's quite a popular name, right? And we use X. So will there be a clash because they are ambiguous, right? Python will say which container because I see a few X's. But remember, just now we were saying variable names must be unique, and it is the scope of uniqueness that we are talking about when we say scoping. What do you mean by unique? To what extent is it unique? So for that, we need to think about a layered approach, a modular and layered approach towards the idea of uniqueness, and that's called scoping. So namespace is like attaching a surname, a family name, to the same given name, such as John, right? So if there are two Johns in a classroom, in a meeting room, and I say John, hi, and there'll be two people raising their hands or greeting, hello, hello, so there's a clash. Whom am I talking to? However, if I say hi, John Smith, because the other John is John Williams, then it will be clear because I'm saying, hey, John Smith, how are you? Right? So only one person will respond back to me because it's unique. So by having family name attached to the first name, this becomes clear. Now, obviously, this analogy will only work to certain extent because it's also possible that we have two exact same name persons like John Smith and John Smith together. But you get what I'm trying to say. So by including the family name, we are able to uniquely identify a person in general. Same thing here. Even though the so-called given name, the variable name, is referenced as X, but because Python contains or has this idea about namespace, this X is used in this program, or we call the module here, and that X is in the systems module, and the other X is in your teammates' differently named module. They don't clash because I know precisely which X you're talking about. So when we use our X here without any explicit namespace change, then this refers to our program's global namespace. It is the outermost namespace that our program has. So whenever we didn't say anything, that's a global namespace in our module. In our module simply means in that Python file. When we run a file like this, this is a module as well, and I'm just going to use them interchangeably, although there are slight differences that are not important in our discussion now. So when we say X, actually what this means is everybody here, whichever statement can refer to X, and it means our program X. It is not somebody else's X. Most importantly, it is not the systems modules. It is not the mathematics module. It is not the timing modules X. They might have used X internally, but that is not my X. My X is my program dot X. All right, so the first part, my program dot, is not there, but there's no clash. Python knows uniquely what this X is talking about. Okay, so that's called a global namespace. Our program at the outermost level, that means not indented, it's global, right? Every imported module has its own namespace. Whenever we import math, that math module containing sine, cosine is actually parked under math.sine. it's not just sign alone, SIN. We cannot just call that function. We have to call it by its complete name called math.sign function, or math.cosine function, or math.logarithmic function, because those are parked under the family name, or rather the module name called math, M-A-T-H. So why go through all that trouble? It's because someone else in other parts of the world trying to write this very accurate and high-speed math algorithm, all the functions, for us, when we just call it and run it, right? That person has the liberty and at different times think about using X. And now you're also using X. And there should be some sort of automatic traffic control, right? To say that when he or she wrote the X in the mathematics module that we now use, shouldn't clash with our choice of using X in labeling our containers and by referring to that container as our X. There shouldn't be a clash. There shouldn't also be a need for them to check with the whole world. Hey, please don't use X because I'm using it. Please don't use X, I'm using it. Okay, so it shouldn't be such a need, which is impossible, to make it a very powerful and effective practical programming language. So Python manages that with the sense of with a mechanism called namespace. Okay, so in this particular program, let's just let the actual Python tell us. It so happens that inside this system function called OS, operating system, there is this label, this variable called x underscore OK. And it's a variable defined under the OS, this OS module. So that when we import OS, we are able to start using a lot of those system functions, such as opening a file, writing to it, and so on. And incidentally, this module also contains a predefined variable called xok, right? If we run this, what happens? When we define our variable x, we label that container x and puts in a value called 123. So when we access it, of course, 123 is printed. And when we print xok, well, this xok, capital XOK, is functioning in no different way than our little x, because it's just saying, give me another empty container, label that xok, and now store a value called 567 inside, right? So now we access it. That's the same way as accessing variable x here, just reading the value back from the container. So Python correctly prints that. Next, when we import OS, now look, let's look at what OS does. Okay, OS has a lot of methods. Okay, that module has a lot of read and write and all that. But more importantly, it also has certain predefined variables like xok, right? And this xok is a variable that is parked under OS, not under our program. But we didn't know. And we wanted to use this label called xok, and we sort of impose it with a value 567. So there is a bit of a clash, but no clash. Why? Thanks to namespace mechanism. So because of that, we are able to access our original x, because we had no idea that OS actually used this variable x underscore OK, right? So we are able to then access x, and in particular, we are still able to access our own xok because we think it contains the value 567. And our act of assigning this shouldn't affect OS, because if the xok under OS module is being affected, instead of writing one time to hard disk, for example, it may write 567 times. Instead of one representing write, 567 may mean write and delete or whatnot. So all I'm saying is that changing the assumed values in other modules might cause disastrous outcomes, and we don't want that to happen, right? So let's check: is the xok inside the OS module still contain the same value as before. That means not affected by our XOK statement here. And the answer is yes, it is still retaining its original value, because the right way to access that is give the full surname and given name. So we have os.xok. Yeah. So xok is our value. os.xok is operating system's modules xok. So the names are the same. It's like my xok is the John here. Hey John, without the surname, Python will look for the variable name that is in our space, and that has to be unique. The moment we say xok equals to 789, number one, even though right now Python is aware that OS also contains an xok, there is no ambiguity in us saying, let's assign a new value 789 to our container called xok. Python knows this is about your global scope here, inside your program. It's not about another module's xok. All right. So we ask, what is our xok? The new value. What is operating system module's xok? No change, because we only write to this unique container name called xok in our global space. The module OS's xok is not touched, and we better not change it, even though we can, but we should not change it.